through a couple more examples here. We're going to look at one where you're looking for one of those k things. This is one of those questions that you see a lot on DP things like, what must the k be? Or prove that k must always output positive values, or whatever the case may be. We'll look at more of those on our DP Monday night meetings when we look at those DP questions. So 2 of the roots of x cubed minus 3x squared plus kx plus 75 equals 0 are opposites. Well, how many roots are there? It's a cubic, there must be 3. So one of them is alpha, and the word opposite indicates that the other one's the same number, but negative. And then we have a third root, beta. So alpha plus the opposite of alpha plus beta equals 3, which means the sum of the roots is just beta equals 3. So that's kind of cool, because then we can start to talk about what our function is going to be. We know that the second term is going to be 3x to the second. Cool. Boom, got it. So the product then of alpha times the opposite of alpha, negative alpha, times beta equals negative 75. Well, now that I know that beta is 3, I can just plug in 3 there. So alpha times negative alpha gives us negative alpha squared equals times 3 equals the product. Okay, here our product is 75, and it's a cube, so it's an odd power function, which means this is one of those opposite ones. If you ever are confused, you can always take negative 1 and raise it to the highest degree, and if you get 1 positive, that means this number is positive, or exactly what it is. I don't have to multiply by negative 1. And if I raise it to, in this instance, like a 3, I can see that I get negative 1, so I do need to make this opposite. So positive 75 becomes negative 75. Divide out the 3, divide out the negative, so alpha squared is 25, which means that alpha is 5. So if alpha is 5, and that means alpha's opposite is negative 5. So our 3 roots must be 5, negative 5, and 3. Cool. Let's write it out. We found the roots, so we found the first part, and what is the value of k, which means we're going to be multiplying this back together. So this term right here gives us this one, this term right here gives us this one, and this term gives us this factor. So multiply them together. X squared, these are perfect difference of perfect squares, so we're going to get x squared minus 25 times x minus 3, multiply out. X squared times x gives us x cubed. Negative 25 times x gives us negative 25x. Oh, we already knew what our answer was going to be for the other components, right? So why not just stop? We figured out what k is going to be, since we multiplied the only 2 numbers together that would give us a linear term. So that means that negative 25 must equal k. Cool. Check. Moving on. I want to look at one other way that we might use this. We're going to look at one that is a quartic. So 2x to the 4th minus x cubed minus 4x squared plus 10x minus 4 equals 0 for some x's, right? And what I want you to know is that one of the zeros of the equation is 1 plus I is one of the roots. Okay, and it asks, what are the other 3 roots? Question mark. I'll get you started. I'll do the easy one. Hopefully this is the easy one. If 1 plus I is a root, then what do we remember? They always come in conjugates. 1 minus I is the other root. And I'm going to put in my 1 there. Remember, we've got to divide out our 2. So this becomes x to the fourth minus 1/2 x cubed minus 2x squared plus 5x minus 2. And then it's a quartic, so this is actually what the product is. So -2 is our product. And -1/2 is our sum. And so we have our first root and our second root. And then we'll call our third root alpha and our fourth root beta. Okay, so I want you to see if you can figure out, using sums and products rules, what the third and the fourth root would need to be in order to make these four terms add together to give you this, or multiply together to give you this. Okay, so if you can't figure out how to do it using sums and products, you're welcome to try another strategy with long division. And if that doesn't work for you, we can go over it when we come to class tomorrow. But I'm sorry, not tomorrow. We'll go over it Tuesday. So remember, this is your pre-homework. I want you to think about this and try this problem before you come to class on Tuesday. So we're going to do half of 3 up to sums and roots on Monday, the first time I see you, and then we'll go over, the other half of 3, which is this stuff, sums and products, on the second time I see you, which will be Tuesday this week. And then if you have any pre-questions on how to go over this, you're welcome to stop by and we can go over it as a class before, one-on-one before we go over it as a class.